So here I'm going to discuss about the iron sulfur protein, where this is the first type of iron sulfur protein, that is one where is one iron and zero sulfur. That means there is no sulfur, there is only one iron, that is one iron and zero sulfur protein. So here the simplest type of iron sulfur proteins, that's a rubridoxin, that is found in bacteria. So here this act as they can act as the one electron donor or acceptors, and the iron atom, that is look at this structure. This is the iron atom that is bound to 4 cysteine residues. Okay, this is a obviously this is a tetragonal distorted tetragonal structure. So here this iron atom that is bound with to 4 cysteine residues. So this is a 1 iron and 0 sulfur protein. Okay, here so iron sulfur distance, that is 2 to 4 and 3 to 33 pm, and here reduction potential, that is Fe3 plus to Fe2 plus, that is minus 0.06 volt. Okay, so now I'm going to the next part, that is the ferredoxins. There are three types of ferredoxins, where there are 2 iron and 2 sulfur proteins, and 3 iron and 4 sulfur proteins, and 4 iron and 4 sulfur proteins. So in the first one, there is 2 iron and 2 sulfur proteins, that is isolated from mammals, plants and bacteria, and it has a dinuclear structure. Where 2 tetrahedrals shares a common edge containing inorganic sulfur atoms. Okay, that's why it is a dinuclear structure, or Fe3 plus bond distance, that is 269 picometer, and here both are high spin complex, and here strong antiferromagnetic coupling that gives a diamagnetic cluster. Okay, so the next structure you can see here in the next structure, where Fe2 plus Fe3 plus clusters containing D6 system, that is high spin complex, and D5 system, that is high spin complex, that is the D6 and D5 pair. Okay, for reduction potential, that is near about the minus 0.15 volt to minus 0.45 volt. And here look at the structure, where in this Fe3 plus ion, that is attached with 2 N-histidine groups, and in this part that Fe2 plus, that is attached with the S16 or S16 to S16 groups. So that is a non-symmetrical structure. Okay, if we cut this the structure, so we get a non-symmetrical structure. So that's why this is a non-symmetrical structure, where that is found in risque proteins, that is isolated from bovine mitochondria. Okay, the next is, that is 3 iron and 3 sulfur proteins, where that is found in azobacter, and you can note this the Finlandi and Disal Fabrio gigas. Okay, that is found in Acidobacter Finlandi and Disal Fabrio gigas, and this is also present in Aconites from pig heart. So here the structure. Now I'm going to the structure, that is a structure may be derived from that of the Fe4S4, that is 4 iron and 4 sulfur. Okay, units by removing 1 iron. So look at this is a structure of 4 iron and 4 sulfur protein, where there are 4 iron. Okay, 4 Fe are there. So if we remove 1 Fe from here, so we get this 3 Fe and 4 sulfur protein. Okay, so here these are the similar like structure. Okay, that is cuban structure. So first of all, you can draw a cube and then attach the iron and sulfur in this corner of the cube. So the next is, that is 4 iron and 4 sulfur proteins, where that is a distorted cube structure. Okay, or you can say that is a cuban like structure, and with iron atoms at alternate corners of the cube. So you can draw the structure like this, and do not memorize this. Do not memorize the structure of the 4Fe4S protein. you can draw easily the structure like this. First draw a cube and don't attach the corners. Okay, so leave these corners like this, and for there will be some atoms. So for Fe4s there mean 8 atoms are there. Okay, and we have 1 2 3 4 5 6 7 8 8 corners are also there. So we can easily attach this atom in these corners. So now for Fe, so you can take anywhere like this. If you take this ferrous iron in this corner, so there will be at it will be attached with sulfur atoms. So here is also sulfur, there is also sulfur, there is also sulfur. Okay, so 4 sulfurs are there, and we get 4 sulfurs in this structure. So there will be also ferrous, and ferrous sulfur and sulfur is attached with like this. There is also a ferrous and there is also a ferrous. Okay, so 1 2 3 4 4 iron, and 1 2 3 4 4 sulfurs are there. You can do not memorize the structure, I repeat. You can draw like this. Otherwise you can take any for the iron atom. Okay, so and the S16 groups will attached with bound this ferrous atom like this. S16 S16. Okay, like this S16. That's it. And you can see the structure also, it was in the book. And obviously you can refer the Ekidas volume 2, it will be helpful to you. So here reduction potential Fe3 plus Fe2 plus, that is minus 0.4 volt, and another high potential form present in some bacteria that has electrode means reduction potential that is 0.35 volt. Okay, so that's it. These are the types of pyridoxine and what are pyridoxines and what is it. That's it. Thank you.